Join me as I take on the challenge of building a complete system engineering model using ontology, and let's see if I can make sense of it all. System engineering and ontology are two concepts that might seem unrelated at first glance, but trust me, they're crucial for modern problem solving. In today's complex world, we're faced with intricate systems that require a deep understanding of their underlying structures and relationships. That's where system engineering comes in. It's all about designing, building, and maintaining these systems. But to do so effectively, we need a robust framework that can handle the complexity, and that's where ontology enters the picture. By combining these two disciplines, we can unlock a new level of understanding and develop more efficient systems. Engineers often struggle to structure complex systems, and traditional methods can be limiting. We've all been there, stuck with a mess of diagrams, flowcharts, and spreadsheets that barely scratch the surface of the system's intricacies. The truth is, our current approaches often fall short when dealing with ambiguity, uncertainty, and the sheer scale of modern systems. It's like trying to fit a square peg into a round hole. It just doesn't work. We need a better way to tackle these challenges, and that's exactly what ontology can provide. Ontology, in its simplest form, is the study of existence and relationships. It's a branch of philosophy that helps us understand how things are connected, why they exist, and how they interact. When applied to system engineering, ontology becomes a powerful tool for creating robust, modular, and maintainable systems. By focusing on the underlying structure of a system, we can identify its core components, relationships, and constraints. This, in turn, enables us to build more efficient, flexible, and scalable systems that can adapt to changing requirements. In ontology-based system engineering, we're not just building systems, we're crafting a deep understanding of the problem domain itself. This allows us to tackle complexity head-on, making it easier to identify flaws, optimize performance, and reduce costs. By embracing ontology, we can shift our focus from purely technical aspects to the underlying essence of the system, creating a more holistic and effective approach to system engineering. Ills of ontology-based system engineering are numerous. For instance, it enables us to model complex systems in a more abstract and modular way, making it easier to analyze and optimize their behavior. It also facilitates communication among stakeholders, ensuring that everyone is on the same page when it comes to the system's structure and goals. Moreover, ontology-based system engineering encourages a more agile and adaptive approach, allowing us to respond quickly to changing requirements and evolve the system over time. In a recent project, I had the opportunity to work with a team of engineers who were tasked with developing a cutting-edge transportation system. The project involved integrating multiple modes of transportation, including buses, trains, and ride-sharing services, to create a seamless travel experience for commuters. Traditionally, this would have been a daunting task, with numerous diagrams, flowcharts, and technical specifications to juggle. However, by applying ontology principles, we were able to break down the system into its constituent parts, identify key relationships, and craft a robust architecture that accounted for the complexities and uncertainties of the problem domain. The result? A highly scalable and efficient system that exceeded expectations and paved the way for future innovations. Another example is in the healthcare industry, where ontology-based system engineering can help create more personalized and effective treatment plans. By modeling the underlying structure of diseases, patient data, and treatment options, healthcare professionals can identify patterns, relationships, and constraints that inform more targeted and efficient interventions. This not only improves patient outcomes but also reduces costs and streamlines clinical workflows. In conclusion, integrating ontology into system engineering is a game changer. And it's an approach that can revolutionize the way we tackle complex problems. Thanks for joining me on this journey, and I hope you've gained a new appreciation for the power of ontology and system engineering. If you have any experiences or thoughts on system engineering, please leave them in the comments below. What topics would you like to explore next?